Hi everyone, so today we're going to be learning about two of the different rules of differentiation, the product rule and the quotient rule. We're going to be using things from the power rule and constant rule lessons, so if you don't remember that, I suggest going back and we are going to dive right into it. Okay, so we are starting off with the product rule. The product rule is used to find the derivative of two differentiable functions. The formula we use for this is f of x equals u times v, and f prime of x equals v times the derivative of u plus u times the derivative of v. Your first product is u, and your second product is the v. So I'm going to show you guys an example. This example is f of x equals 2x squared plus 3 times 3x minus 4. So from here, the first thing we would do is find our u and our v. In this equation, the u would be 2x squared plus 3. Our v would be the second part, the second product, which is 3x minus 4. So let's write that down. V equals 3x minus 4. Our u prime is going to be the derivative of u. So we are going to find the derivative of u, which is how we used our power rule. And so our derivative of u is going to be 4x. And now we're going to find our derivative of v, which is going to be 3. Then from there, we are going to plug in the equation that we just learned. But just for reference, let's write it down. And the equation is v times the derivative of u plus u times the derivative of v. And now let's plug that into our equation. Our v, which is 3x minus 4, times 4x plus 2x squared plus 3. And then times 3. And so now we are going to simplify and find it. 4x times 3x is 12x squared. And then 4x times negative 4 is negative 16x. And that's going to be plus, and we're going to multiply the other side. 3 times 2x squared equals 6x squared. And then 3 times 3 is 9. And we're just going to combine like terms, and we are left with f prime of x equals, give me a sec, 18x squared minus 16x plus 9. Pretty simple, and that is our first example. We're going to do another example to kind of get used to these kinds of equations. And so now let's do our second example, example number 2. And example number 2 is as follows. F of x equals 3x minus 2x squared times 5 plus 4x. And so we're going to find our u, which is 3x minus 2x squared, and our v, which is 5 plus 4x. Our derivative of u is what we're going to find now. Let me use a different color for that. U prime equals 3 minus, we're going to do the power rule there, and that's going to be minus 4x. Okay, and then we're going to find the derivative of v now. So the derivative of v is just going to be 4. Let me write that down. And now we are going to use our equation for this, which is v times the derivative of u plus u times the derivative of v. And plugging in our equation to this, f prime of x equals 5 plus 4x times 3 minus 4x plus 3x plus 2 minus 2x squared times 4. And so now we are going to do our math for that to simplify that, which is going to be 5 times 3, which is 15, then 5 times negative 4x, which is negative 20x. Then 4x times 3, which is 12x, and then we are going to do 4x times negative 4x, which is negative 16x squared. Let me move my equation because I don't think I'm going to have enough space for all of this. Okay, and so we're going to do the other side now. 4 times 3x is going to be our first thing to multiply, which is going to be 12x, and then 4 times negative 2x squared, which is negative 8x squared. And then from there, we're going to combine like terms. So our f prime of x is going to be, let me do the math here real quick. Negative 16x squared minus 8x squared is going to be our first thing. And that is going to be, give me a second. Okay. That is going to be negative 24 x squared, and so that's those two. I'm just crossing them off to indicate that. And then we're going to do now negative 20x plus 12x plus 12x, which is the next part of our equation, which is going to be plus 4x and then plus 15, and that's our answer. And we're going to move on now to the quotient rule. Okay, so now we're introducing the quotient rule. The quotient rule is used to find the derivative of a quotient. So this rule is very similar to the product rule, except that there are some differences which we are going to see now. And the first thing I'm going to show you guys is the formulas for the quotient rule that we are going to be using. The first one is f of x equals u over v. And the second one is f prime of x equals the v times the derivative of u minus u times the derivative of v over v squared. And so basically for this, the numerator of any equation we have for the quotient rule is going to be our u, and the denominator is going to be our v. And then based on our numerator and denominator, our u and our v, we'll just plug that into the formula like we did with the product rule. So we are going to do an example for this one to show you guys how to do it. So this is going to be our first and only example for the quotient rule. And our example is f of x equals 5x plus 1 over 3x. And so we are going to find our u and our v. That's the first thing. Our u is the top, our numerator, which is 5x plus 1. And now we identify our v, which is going to be 3x. So let's write down our v, 3x. And then just like the product rule, we find the u prime and the v prime. The derivative of u equals 5. And the derivative of v equals 3. And then from there, we plug it into our equation. Let's write down our equation first. Our equation is f prime of x equals v times the derivative of u minus u times the derivative of v all over v squared. So now that we have that, we're going to plug in. It's going to be 3x times 5 minus 5x plus 1 times 3. And then that's going to be all over 3x squared. And so now we are going to just multiply, which is 15x, and then 3 times 5x, which is minus 15x, minus 3. Let me make sure. Yeah, that's minus 3. And then that's all going to be over 3x squared. And then the 15x's cancel out, and we are left with f prime of x equals negative 3 over 3x squared. And that is our answer. Thank you guys for watching the video.